Hi everyone, this is Aruna, Assistant Professor, Department of Information Technology, SNS College of Technology. In my lecture series today, we're going to see about the minimal cover. Before watching this video, kindly watch my previous video. In that, I have deeply explained about the functional dependencies and axioms for the Armstrong, and also I have explained the closure set. So because why I'm saying this thing means minimal cover can be depend only on this thing. Through that only we can able to identify. We're going to reduce the functional dependencies. So you can watch that one. So before entering into this thing, first we can see about the minimal cover. Minimal cover also can be called it as a canonical cover, or also we can call it as a irregular functional dependencies. These are the other names of the minimal cover. So the canonical cover, which is can be call it as we're going to minimize the set of the functional dependencies. How we can minimize the thing? For example, if F is a functional dependencies, your canonical cover can be represented as a F dash. Similarly, how we can calculate the closure means we are using the F plus. Here we're going to use the F dash. F dash is nothing but the canonical cover. F can be representation as a functional dependencies. In this functional dependency, we're going to reduce the functional dependencies. So how we can reduce the thing means your functional dependencies or your canonical cover should not contain the extraneous attribute or the redundant attribute. And also it should not contain the redundant functional dependencies. If your functional dependencies can have this thing means that we have to eliminate it, and after eliminating this thing, that particular functional dependencies only we can call it as the canonical cover. So how we can calculate this thing means we have to use these 3 steps for calculating the canonical cover. One is we have to split the rule so that every in a functional dependency right hand side must have a single attribute. You have to assess that one. Second thing is if any extraneous attribute or redundant attribute present in the left hand side means that we have to remove it. The third thing is you have to remove the redundant functional dependence. Either it may be a direct or a indirect. If you want to direct, while seeing itself, we can able to identify. Suppose A tends to B, A tends to B. This is a redundant. If A tends to B, A tends to C means whether A tends to B is a redundant attribute. How I can calculate means we have to calculate the A closure. Through A closure, if I can able to identify the B means that it is a redundant attribute. That I will going to explain along with the example. Let us see the example. For this example, I have to given the AB tends to C, C tends to AB, B tends to C, ABC tends to AC, A tends to C, AC tends to B. So in this functional dependencies, we're going to calculate the minimal cover. And also while splitting the rule, I said that first statement is we have to, in the right hand side, we have to convert it into a single attribute. In this case, see through that here it will be a right hand side, you are having a 2 attribute. Here also your right hand side having a 2 attribute. So we're going to rewrite as AB tends to C, C tends to A, C tends to B, B tends to C, AB tends to A, ABC tends to C, because ABC tends to A, ABC tends to C, A tends to C, AC tends to B. In this thing, if you have any trivial attribute, that also we're going to eliminate. These both are the trivial attribute. Why I'm saying it is a trivial attribute means Y is the subset of X. So A is the subset of ABC. Here also C is a subset of ABC. So these both the thing is a trivial attribute that we're going to remove it over here. Remaining thing we have to check either left hand side can have a dual attribute or not. See here AB tends to C. Through C itself, B itself, I can able to identify the C. B itself, I can able to identify the C. So why can't I have to use AB tends to C? Here, A is my extraneous attribute because only B itself I can able to identify C. Why AB itself, I don't want this thing. This can be called it as an extraneous attribute. This is a one case. If I have seen A tends to C, if I consider this functional dependency through that B is an extraneous attribute. Through A itself, I can able to identify C. In this case, B is an extraneous attribute. It can be varied from person to person. If I consider this functional dependency, A is my extraneous attribute. If I consider this one, B is my extraneous attribute. So in this way, we can eliminate the extraneous attribute present in that thing. So that only I have to put it over here. B tends to C tends to A, C tends to B tends to C, A tends to C, A tends to B. I have removed this extraneous attribute. Now I have to remove the either any redundant attribute present it over here. So for example, if I consider B tends to C, is there any B tends to C in the relation? Yes, it is present. So directly we can eliminate this one. Next, I have to check C tends to A, whether it is a redundant attribute or not. So you have to remove this thing by using a remaining thing. If I can able to identify the A while calculating the C closure, after omitting this functional dependency, if can I able to identify the A means, then that particular thing is a redundant attribute. So I am going to omit this one. Now I calculate the closure for this one. Through that, I can able to identify only C and B. I can't able to identify A. So this is not a redundant attribute. Similarly, C tends to B. C tends to B is whether it is a redundant or not. I have to omit this one. Through that, I can able to identify or not. If I check C cross, if I calculate a C, A, B, B, I can able to identify. So this is a redundant attribute. Similar how we have to identify we're going to remove the redundant functional dependency present in the relation. After removing everything, the functional dependency C tends to A, B tends to C, A tends to B. This is the functional dependency. Though, so this particular functional dependency only called as a minimum closure or a canonical cover. So here we are having these many functional dependency that I'm going to convert it into minimal number, because here 1, 2, 3, 4, 5, 6, 7. Now I have converted into 3. This is the how we can eliminate the redundant functional dependency present in the given functional dependency. And also I gave you one example problem, 2 example problem. You can try it in your home. If you have any query for answer, you can send me the comment in my YouTube link. So thank you for watching my video. In my next session, I'm going to explain about the normalization.